Hi students, good afternoon. Welcome to this video session. My name is Samuel Chukwu Emeka, as usual. In this video session, we shall discuss the topic of probability. And it is in your Module 5 and Module 6. So let's get on my website, Finite Mathematics Notes. The video would be in this playlist, and this will be a Module 5 homework study guide. What do we mean by probability? We have done this in the video on probability. So please, I would like you to view this video, probability part 1, before you continue with this video. If you view this video, it will give you the required knowledge that you need in order to understand what we shall do in this particular video. So at the end of this video, I expect that you will apply the rules of probability. You will compute the probabilities of events using the classical method. You shall also interpret the probabilities of events using the classical method. Then you shall compute the probabilities of events using the empirical method, interpret the probabilities of events using the empirical method, and solve problems involving the different types of events: dependent events, independent events, mutually exclusive events, and complementary events. So please view this video first. Question 1. Does the table represent a probability model? If you add up all these, the probabilities, we say that the sum of the probabilities of all events must be 1. So if we add up all these, let me get my calculator here. If you add this up, 0.25 plus 0.2 plus 0.15 plus 0 plus 0.35 plus 0.1. So this will be 1.05. It is not gonna be possible. The probabilities of the probability of an event must lie between 0 and 1. 0 is the probability of an event that will never occur, an event that will never happen. And like an example, probability that a man would be pregnant. You know, it's only women that are pregnant. Have you seen any man pregnant? So 0 is the probability of an impossible event. For example, the probability of selecting the color brown is 0. Yeah. So if you add up all the probabilities, it should always give you 1. But if you add up this, it does not give you 1. Because of that, this is not a probability model. Then we say that 0 is the probability of an impossible event, or an event that will never happen. 1 is the probability of an event that must happen. For example, the probability that Jesus Christ will come again to judge all mankind, that is 1. So all probabilities of all events must lie between 0 and 1. It should not be less than 0, and it should not be greater than 1. probability of an event will never be negative. It should be less than 0, less than or equal to 0. It should not be less than 0. It should be greater than or equal to 0, and it should be less than or equal to 1. 0 being the probability of an impossible event, and 1 being the probability of an event that must happen. So if you also look at question 2, which of these could be the probability of an event? 1 can be, 1.37 no, 0.26 yes, negative 0.52 no, 0.05 yes, 0 yes. Okay, so these are that. Question 3, we have the sample space consisting of numbers 1 through 10, 1 and 10 inclusive. Assume the outcomes are equally likely. Compute the probability of the event. So if we look at these, the event has 2 numbers here. So the cardinality of this event is 2. The elements in the set, the event is a subset of the sample space. So the event has 2 elements, 3 and 10. So the cardinality or the cardinal number of the event is 2, and the cardinal number of the sample space is 10. So the probability of this event, this is the formula. We did this in the in that prerequisite video. Probability of an event is equal to cardinality of the event divided by cardinality of the sample space. So this is 2 over 10. Of course, you have to simplify the fraction, and that gives you 1 out of 5. Question 4. A bag of 100 marbles contains 35 red marbles, 30 yellow marbles, and 35 purple marbles. What is the probability that a randomly selected marble is purple? So the event will be what? 35 purple marbles. So the cardinality, how many purples do you have? The cardinality of the event of selecting purple will be 35. And of course, the sample space, they told us it is a bag of 100 marbles. But assuming they did not give us 100 marbles, you can get the sample space by adding these 35 plus 30 plus 35, and that gives you 100. So you have 100 marbles. What is the probability of selecting a marble that is purple? And that will be 35 out of 100. If you divide both the numerator and the denominator by 5, you will get 7 out of 20. Question 5, we have the probability of an event to be 40%, 0.40. Let me say this, and I said that in the previous video, in the prerequisite video. The probability of an event can be expressed as a fraction, or as a percentage, or as a decimal. I repeat, the probability of an event can be expressed as fraction, or decimal, or percentage. So the question, you just have to look at what they want you to express it in. If they want you to express it in fraction, then you have to express it in the simplified form, in the simplest form of the fraction. If they want you to express it in decimal, you have to express it in decimal. If they want you to express it in percentage, you have to express it in percent. Okay, so we have the probability of event E, which is 0.40, probability of event F, 0.40, probability of events E and F. This is like intersection. The and is like the intersection. It will also be good if you view sets, videos on sets. That would also be good because they are related. Sets and probability are related. So probability of E intersect F gives you 0.10. Find the probability of E or F. Or is the union F. So this is a probability of E or F. We use the addition rule, and this is the formula right here. You might want to take it down. This is the formula. So when you do that, you get 0.7. Question 6 is basically the same format, but in this question 6, they want us to find the probability of F. So you do the equations, right? You use the literal equations. You isolate this. You isolate a probability of event F. Okay, you isolate it. So you can move all these here. If you don't know how I got this, please view my videos on equations, linear equations, and literal equations. Linear equations and literal equations. So, but we just use the addition rule. And this is the addition rule right here. Question 7 is a complementary events. Some textbooks will say complement rule. Okay, some textbooks will have it as complement rule. But complementary events are events that are like opposite each other. Like if the probability that John will come to school tomorrow is 1/4, then the probability that John will not come to school tomorrow will be 3/4, which is 1 minus 1/4, which gives you 3/4. So the probability that John will come to school tomorrow plus the probability that John will not come to school tomorrow will be 1. So if you want to find the probability that John will not come to school tomorrow, okay, let's say that the event E is the event that John will come to school tomorrow. So probability of E complement means the probability that John will not come to school tomorrow. And that will be 1 minus the probability that John will come to school tomorrow. So this will be 1 minus 0.24, and that gives you 0.76. Question 8 deals with the multiplication rule. This is the formula for multiplication rule. You just multiply the two probabilities. That is the multiplication rule. Question 9. What is the probability of obtaining 2 heads in a row when flipping a coin? Round your answer to 5 decimal places as needed. I have talked about this as needed before. As needed means if you solve it and your answer is not up to 5 decimal places, then you put zeros to complete it to 5 decimal places. If you solve the question and your answer is more than 5 decimal places, then you round. Okay, you round to 5 decimal places. So that is what as needed means. I gave you this formula. And don't ask me how I came up with this formula, because I have not seen this formula in any textbook, honestly. So, but I have been teaching probability, so this formula works. It even works for die. The dice, your fair die that has we call it Ludo game. We use it in Nigeria. We call it the Ludo game. But in this case, it works for dice. It also works for coins. The cardinality of the sample space is faces exponentosis, and it works. This formula works. if you have seen it in any textbook, let me know. Okay, but I have been using it and it works. Okay, when you have this kind of question, you don't solve it for every question, but when you have this kind of question, tossing a coin 3 times, tossing a die 2 times, tossing 2 dice 1 time, okay, it works. So the cardinality of the sample space, you have a coin tossed 2 times. So a coin has 2 faces, so that is 2 exponent. You toss it 2 times, so that is 4. So the sample space is 4. And in the prerequisite video, I showed you how to get it, because you can have a head, tail, head, or tail. So the sample space is 4. Whenever this happens, you get the possibility of getting head is just 1. If you view the prerequisite video, you will know why it is so. I explained it there. So you have 1 out of 4, which will give you 25%. And they want you to round to 5 decimal places as needed. In this case, 25% is 0.25. 0.25 is only 2 decimal places. It is not up to 5 decimal places. So you have to add the 3 zeros to make it up to 5 decimal places. Do you understand? And what does this probability mean? It means that if you toss a coin 2 times, now if you toss a coin 2 times, it is the same thing as saying tossing 2 coins 1 time. It is the same thing. In case if you see another question that says 2 coins were tossed 1 time, it is the same sample space. Tossing a coin 2 times or tossing 2 coins 1 time is the same. So this will be if you 25% means 25 out of 100. So that means that if you out of 100 times, it is expected that 2 heads in a row would occur about 25 times. You get about 2 heads about 25 times if you toss it 100 times. That is what it means. Okay, question 10 is the same principle. In this case, 7 heads in a row. So that would be 2 exponent 7, and that is 128. In this case, the answer is more than 5 decimal places, so you round. Okay, when you round, you get this. You round to just 5. That is what 5 decimal places as needed. That is what as needed means. So if you round, you now get that. So this is almost 1 if you round it up. If you round it up, this is almost 1. So if you toss this 100 different times, it is expected that 7 heads would occur about 1 time, because this is almost 1 if you round it up. Does that make sense? Because this would be like saying 78125 divided by 100. Okay, and when you do that, 78125 divided by 100. This is 1 divided by 128, and you get this. Okay, you get this, and if you want to express this as a percentage, you multiply by 100. So that will be 0.78125%. So this is almost approximately 1. So that means that if you toss it 100 different times, it is expected that 7 heads in a row would occur about 1 time. That is what it means. Okay. Question 11. Suppose Ted loses 80% of all arm wrestle contests. Do you arm wrestle? What is the probability that Ted loses 2 arm wrestle contests in a row? Do not round your answer. For question A, do not round your answer. For B, what is the probability that Ted loses 5 arm wrestle contests in a row? For B part, round your answer to 4 decimal places as needed. So the probability that Ted loses arm wrestle contest is 80%. Okay, so that means 0.8. In this case, we shall use the multiplication rule. For the A part, what is the probability that he loses 2 arm wrestle contests in a row? So the probability of the first loss times probability of the second loss. That gives us 0.8 times 0.8, and that is 0.64. B part, what is the probability that Ted loses 5 arm wrestle contests in a row? The same thing. It's multiplication rule. You multiply 0.8 up to 5 times. If you don't want to do this, multiply it up to 5 times, you can simply do 0.8 exponent x raised to power y exponent 5. And that will give you 0.32768. But they want you to round it to 4 decimal places as needed. So this is 5. So you run 1, 2, 3, 4. 8 is more than 5. Call it 1. Add to 6. Becomes 7. Yeah. So if you don't, if you might make mistake of doing 0.8 times 0.8 times 0.8, maybe you count it more than 5, then you might just do 0.8 exponent 5. Question 12. Question 12. About 12% of the population of the U.S. state of Alabama smile at strangers. Have you ever noticed that? Okay, if 2 Alabamians, Alabamian is someone from Alabama. If 2 Alabamians are randomly selected, A, what is the probability that both smile at strangers? This is multiplication rule. The 12% means 0.12. So probability that 1 Alabamian smiles at strangers will be 12%, 0.12. So probability that 2 Alabamians smile at strangers will be the probability that the first one smiles at strangers and that the second one smiles at strangers. So that would be 0.12 times 0.12, and that gives you 0.0144. B, what is the probability that at least 1 smiles at strangers? Round to 4 decimal places as needed. Okay, so for the B, at least 1. If I ask you, hey, Joe, could you please give me at least 5 oranges? At least 5 means 5 or more. You can give me 5 oranges, you can give me 6 oranges, you can give me 7 oranges, you can give me 8 oranges. If I ask you, Joe, please, can you give me at most 5 oranges? At most 5. That means 5 or less. You can give me 5 oranges, you can give me 4 oranges, you can give me 3 oranges, or 2 oranges, or just 1 orange. If I say, Joe, could you please give me exactly 5 oranges? Then that is just 5. So at least 5 means 5 or more. At most 5 means 5 or less. Just 5 or exactly 5 means equal to 5. So when we talk of at least one, we have both two Alabamians. So it could be that the first one smiles and the second one did not smile, or when you say the or, it is now addition rule. The multiplication rule is that the first one smile and the second will not smile, or addition rule comes into play. The first one does not smile and the second one smiles. Okay, that is multiplication rule. Or addition rule, both of them smile. So when you do that, you now have to find what is the probability that the second will not smile. So probability that one smiles will be 0.12. Probability that one will not smile, that is complementary event, that will be 1 minus 0.12. And that gives you 0.88. So probability that first smiles and second does not smile, that is multiplication rule, which is 0.12 first smile and times second does not, 0.88. Or is the plus. Okay, first does not, which is 0.88 times second does, 0.12. Or is plus. Both of them smile. We already have that here, 0.0144. And if you add it up, it gives you 0.2256. Comprenez-vous? Question 13. A test to determine whether a certain antibody is present is 99.5% effective. This means that the test will accurately come back negative if the antibody is not present in the test subject. The probability of a test coming back positive when the antibody is not present, in other words, a false positive, is 0.005. Suppose the test is given to 5 randomly selected people who do not have the antibody. Question A. What is the probability that the test comes back negative for all 5 people? So they said here the test will come back negative if the antibody is not present. So the probability of negative is 99.5%, which is 99.5 divided by 100, which will give us 0.995. The probability of positive is 0.005. Of course, if you add both of them, it gives you 1. Remember, 1 is the probability, the total sum of all probabilities. So this is a probability model. What is the probability that the test comes back negative for all 5 people? So this is multiplication rule. Okay, first one is negative, and second one is negative, and third one is negative, and fourth one is negative, and fifth one is negative. So this will be 0.995, multiply it by 5 times. Or you just do exponent 5, just like I showed you earlier. And that will give you 0.9752. Question B. What is the probability that the test comes back positive for at least one of the 5 people? Round to 4 decimal places as needed. So if you're looking at this now, it could be at least one of the 5 people. So it could be 1, or it could be 2, or it could be 3, or it could be 4, or it could be all 5. Here they did not give us the order. It's in any order. They didn't tell us. If they had told us what is the probability that the first person is positive, then rest of the 4, second person is negative, third person negative, fourth person negative, fifth person negative, then that would be very easy to solve. But they just said at least, for at least one of the 5 people. So it could be the first one positive, the other 4 negative. Or it could be the second one positive, first negative, third, fourth, and fifth negative. Or it could be only the third one positive, then first, second, fourth, fifth negative. Or it could be only the fourth one positive, then first, second, third, and fifth negative. Or it could be only the fifth one positive, then first, second, third, and fourth negative. Or it could be first, second positive, then the third, fourth, fifth negative. I mean, if you keep doing it, if it was the previous one we did, it was easy. First one does not smile, second one smiles. Or first one smiles, second one does not smile. Okay, that is only 2 people, or both of them smile. But in this case, this is 5 people. Come on. It is really, it will be like killing a fly with a hammer if you list everything. P, N, 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 or NP. You list one case, then you list 2 cases. Okay, it could be positive, positive, negative, 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 or negative, positive, positive, negative, negative. I mean, that would be Herculean task to do. Okay, so we can use the formula for complementary events, and this formula will also work for the previous one we did. We can look at it. So probability that at least one is positive plus probability that no one is positive will give us 1. That means that probability that at least one is positive will be equal to 1 minus probability that no result is positive. So that will be 1 minus 0.9752, and that will give you 0.0248. So the same thing goes in the previous one. We could do 1 minus probability that none of them smiles are strangers. None of them smile are the strangers. So if we use that, if the none of them smiles as strangers will be 0.88 times 0.88. So if we do 0.88 times 0.88, or you just do 0.88 squared, so that will give us 0.7744. I studied in memory. I will now say 1 minus recall memory 0.2256. you see. So that is a second method you can use to do that, and it will still give you the same answer. Comprende? I just wanted to use one method here, and of course this other method, if you list the other one, it will take a lot of time, but you will still get the answer right. Trust me, if you list it correctly, you can still get the answer right. Okay, the next one we have, so if you do this, you get your answer to be 0.0248. We say that 2 events are dependent if the probability of one event affects the probability of the other event. And when we see questions like without replacement, then of course we know that that will be dependent. And 2 events are independent if the probability of one event does not depend on the probability of the other event. And we see this if we see questions that usually, that are usually worded with replacement, then of course those events will be independent. Question 15. A pencil is selected at random from a box of pencils. We have several grades of pencils, but in this question we have 7 grade B pencils, we have 4 grade HB pencils, and 9 grade H pencils. Find the probability that the pencil is not a grade B pencil. So you can do it 2 ways. You can use complementary rule complementary events. First of all, find the probability of getting a grade B pencil. So that will be how many grade B pencils? 7 over the sample space, of course, is adding the pencils. 7 plus 4 plus 9 to give you 20. So that will be 7 out of 20. The probability of getting a grade B pencil. Now, what would be the probability of getting of not getting a grade B pencil? That would now be 1 minus the probability of getting a grade B pencil, which is 1 minus 7 out of 20, which will give us 20 over 20 minus 7 over 20. 20 minus 7 is 13. That gives us 13 over 20. You can also use the second method. If you don't want grade B pencils, then that means you can get grade HB pencils or grade H pencils. So 4 plus 9 is 13. You can just do it as 13 over 20. Any of the methods will work. Okay. Question 16. Oh, that was the question I just did. Question 17. The sample space of a probability experiment is this: 4 through 15. If an event, this is the event space, assume that each outcome is equally likely. List the outcomes in E complement. So E complement are what? Those in the sample space that are not in the event space. Okay, so from 8 through 15. So the cardinality is 8. So you find the probability of the complement, and that will give us 8 out of 12, which is 2 out of 3. Question 18 is testing you on what we mean by mutually exclusive events. Mutually exclusive events, they cannot occur at the same time. They are disjoint. They cannot occur at the same time. They are disjoint events. They don't have any common elements. Okay, they cannot occur at the same time. So if you look at their set are mutually exclusive events. They are disjoint events. They cannot occur at the same time. In this case, they are disjoint. And they are also mutually exclusive because they don't have anything. But the main wording is that they are disjoint because they do not have any elements in common. Okay, but you can also say that they are mutually exclusive because they don't have anything in common, which means they cannot occur at the same time. Two events are mutually exclusive if they cannot occur at the same time. And if they cannot occur at the same time, that means they are disjoint. Does that make sense? So the is an empty set. They don't have any element in common. Is an empty set, and their cardinality will be 0. I want to say something here. The set of the outcomes will not be 0. No, it will be an empty set. Phi, this is the Greek alphabet, phi, which is empty set or null set. And the cardinality of the intersection will be 0. Question 19. A loaded die is a die in which a certain outcome is more likely. A fair die is a die in which all outcomes are equally likely. So do you see the difference between a loaded die and a fair die? In a fair die, all outcomes are equally likely. They have almost equal probabilities. But a loaded die, some elements have more probabilities than others. So we are looking at the outcome of this experiment. Does this look like a loaded die or a fair die? If we look at this, the frequency are almost the same. If the frequencies are almost the same, the probabilities will almost be the same. So these are all close values. They are very close to each other. So we can say that this is a fair die, not a loaded die. But if we look at question 20, we have like two outliers here. This is 100, this is 114. So they are like outliers, you know, they have higher chances of occurring. So because of that, this is a loaded die. Question 21. Samuel, Dominic, and Chukwu Emeka. Some of you don't know how to pronounce my last name. Some say Chukwu Emeka, or some say Emeka, Ka. It's not Ka. It's like a rising tone. Emeka. Okay, Emeka, Chukwu Emeka. Emeka means has done a lot. Chukwu Emeka means God has done a lot for me. Chukwu Emeka. So, anyway, you can call me Mr. C. Samuel, Dominic, and Chukwu Emeka work for Southern New Hampshire University Online. The university wants to send 2 employees to a statistics conference. To be fair, the university decides that the 2 individuals who get to attend will have their names drawn from a hat. This is like obtaining a simple random sample of size 2. We discussed this random sampling, simple random sampling in a Module 1 homework. A, determine the sample space of the experiment. That is, list all possible simple random samples of size n equal to 2. B, what is the probability that Dominic and Chukwu Emeka attend the conference? C, what is the probability that Chukwu Emeka stays home? Now, if Chukwu Emeka stays home, that means he doesn't get to go. Okay, he doesn't get to attend the conference. All right, so the sample space could be, this is sample space, samples of size n equal to 2. So, because 2 people get to go. So, it could be Samuel and Dominic, SD, or it could be Samuel and Chukwu Emeka, SC, or it could be Dominic and Chukwu Emeka, DC. So, the sample space will be SD, SC, and DC. The cardinality of the sample space is 3. B, what is the probability that Dominic and Chukwu Emeka attend the conference? So, Dominic and Chukwu Emeka is DC. So, it's just 1 out of 3. If Chukwu Emeka stays home, that means he doesn't get to go. So, it will not be Samuel and Chukwu Emeka. It will not be Dominic and Chukwu Emeka. So, it's going to be Samuel and Dominic, SD. And it appeared only 1 time. So, it will be 1 out of 3 as well. Question 22, last but not the least. In a survey, some students were asked how often they wear seat belts when riding in a car driven by someone else. The response frequencies are seen in the table below. A, construct a probability model for these survey responses. Round to the nearest 1,000 as needed. B, would you consider it unusual to find a student who never wears a seatbelt when riding in a car driven by someone else? So if we look at this, probability is cardinality of the event all over cardinality of the sample space. So you add up all these, you add it up, sigma means summation. We did this in a Module 3 homework. So you add up all the frequencies, it gives you 4805, and then you find the probability of each event. Probability of never will be 0.027 because the number of responses who answered never were 128. So you do 128 divided by 4805, and they want us to round to the nearest thousand. That means 3 decimal places. Okay, so you have that. I will show you with one example. 128 divided by 4805. So you see that 0.027. Okay, let me cancel memory. So when you do that, when you add up all this, is approximately 1. This is the probability model. The sum of all the probabilities should be 1. The second one, would you consider it unusual to find a student who never wears a seatbelt when riding in a car driven by someone else? Yes, because the probability of the never will be is less than 0.05. 0.027 is less than 0.05. Depending on the event, usually some events whose probabilities are less than 0.05, it is unusual for those events to occur. Now it depends on the events. Okay. So the next one are the references. The next slide are the references. Okay, so please watch out for more videos. Thank you so much for listening to this video session. If you have any questions, please feel free to ask. And you have a great evening.